Hello and welcome to StudyIQ. I am your friend Rahul Saigaonker. Let's continue our NCERT science series discussion. You already know on StudyIQ we are running NCERT science discussion where we have already reached class 8. We are going for a chapter by chapter discussion. Already NCERT Science 6 and NCERT Science 7 are completed in bilingual format on StudyIQ IAS channel. If you want to refer to those video lectures for comprehensive understanding, you can always search for a playlist with the ID Rahul Sai 222. This is my social media ID. With this name, you'll find multiple playlists. You'll also have NCERT playlist. Do refer to those videos. As mentioned, today we are talking about class 8 discussion. As I told you, we are doing a chapter by chapter analysis. We are already done with crop production, chapter 1. Chapter 2 is done, microorganisms. Chapter 3, synthetic fibers. Chapter 4 is also done. In our last discussion, we spoke about coal and petroleum. How is coal formed? How is petroleum formed? What are the nuances? What are the differences in those? We have already discussed. Today, we are talking about chapter 6, combustion and flame. By name, it looks very innocuous kind of a chapter, but we are going to get a lot of details about combustion, combustible substances, how combustion begins, what is the meaning of ignition temperature, what is a flame, what is a fuel, what is fuel efficiency, what are the ill effects or what are the adverse consequences of combustion and their residues. All these things would be covered in this video lecture. To get to know all that information, stay till the very end. Let us begin. But before that, if you are preparing for UPSC Civil Services examination, there is a big news from StudyIQ. We are running 2 batches. One is a morning batch, one is an evening batch. You can choose according to your convenience. If you are a working professional, you can always go to your office 9 to 5, finish off your job and then take up the evening batch. If you are a regular aspirant, if you can dedicate time in the morning, start your morning freshly by attending these classes. Both these batches are prelims to interview batch. That means for 2024, we'll be preparing for you. If you clear your prelims examination, your entire mains residential program and its expenses would be taken care of by StudyIQ. This entire program where you will get one-to-one mentorship, group mentorship, current affairs program, everything, it is priced at 29,999. If you want this discounted price, do use my code Rahul Live, be it on the website or on the app. Do it. I'll see you in the class very soon. All right. Let's begin our discussion. Combustion and flames. By the name itself, combustion. It's a part of our day-to-day life, right? Every day we use different kinds of fuel. At my home, we use LPG. You have LPG at your homes. What do? You cook food. You use fuel, right? I just rode my vehicle and came here. How did I come? On the vehicle. In the vehicle, I put petrol, right? Petrol is a fuel which burns. And where does it burn? It burns in the internal combustion engine. In our day-to-day lives, we use so many different kinds of fuel. We use charcoal, we use LPG, we use liquid fuels, solid fuels, gaseous fuels, right? So all these fuels, they undergo a chemical process called as combustion. And we are going to understand that itself, combustion. What does it give us? It gives us heat and light. Flame would be discussed in the latter half. So first things first. What is the meaning of combustion? Combustion. See, for combustion, I need a fuel. I need to ignite that fuel. For that, I need some amount of heat. And for a combustion process to be completed, it needs oxygen. Now, colloquially, we simply use what? We use fuel plus air. And if you provide some heat to it, combustion process starts, right? These are the primary requirements of any combustion process. And combustion process, remember, it is not a physical change. It is a chemical process. It is a chemical process wherein a substance is written as fuel here. I can write fuel here, substance or a fuel. It reacts with oxygen. Colloquially, we use the term air also because in air we have 21% oxygen. It reacts with oxygen to give off heat and light. This is called as the process of combustion. And we have seen solids undergo combustion, liquids also undergo combustion, and gases also undergo combustion. Solid fuel, for example, charcoal. Liquid fuel, we have gasoline, we have petrol, we have diesel. Gaseous fuel, we have liquid petroleum gas. All right. So many kinds of fuel, they undergo combustion to give us heat and light. That's the meaning of combustion. Remember, it's a chemical process it needs oxygen from air. All right, that is when the combustion reaction is completed. And if oxygen is in deficit, then it would be incomplete combustion. See, generally, if there is carbon, right, if there is carbon in the fuel, carbon would react with oxygen to give us heat and light to form basically carbon dioxide. And if oxygen is in deficit, we already know by common sense, it leads to creation of carbon monoxide. So this is incomplete combustion. So it can be complete combustion, incomplete combustion, depending on the amount of oxygen or depending on the amount of air that is available. The next question. So what are these substances? What are these fuels? There, the nomenclature has been given. Fuels are divided into, or substances are divided into combustible substances, non-combustible substances. Combustible substances are those which basically burn in air. They give you heat and light. Non-combustible means which do not burn. They do not burn. Now, in our day-to-day life, we come across so many combustible substances and non-combustible substances. For instance, if I look around here in the studio itself, I'll find there is a carpet or a mat, which is a combustible substance, right? For instance, this glass that I have, the plastics, no supporters here, they are combustible, but the metal and the glass that are not combustible, right? So in our day-to-day life, we see so many combustible and non-combustible substances. Here is an example. Say wood. Wood is a combustible metal. It burns. Paper is a combustible metal. It's made up of wood pulp itself. Iron nails. You have iron nails. They do not burn. You throw them in a fuel, or you throw them in a fire, they come across. They will get heated for sure because they are good conductors. We saw about metal. This is a metal. It's a good conductor of heat and electricity. It conducts heat, but it does not burn. Kerosene, it's combustible. Stone is not combustible. Stone also heats up. You do know that if there is a fire and if there is a stone in the fire, that stone would be heated up because it gathers that heat and it dissipates that heat, but it does not burn. Straw is combustible. Charcoal is combustible. Matchstick is combustible. Every day we use matchstick, right? For lighting purposes, for igniting, that is combustible. Glass is non-combustible. That is why I gave you an example. When I took this out, this is made up of metal. The frame is made up of metal. It's not combustible. The glass, it's not combustible. But the no supporters, they will burn off. All right. So combustible and non-combustible material. All right. Next, let's talk about some information that is provided in NCERT. Now we all know sun. In sun, there is something burning because sun also gives you heat and light. So can we say that sun is also undergoing some sort of combustion? See, in sun, it's actually not the process of combustion because remember, there is no oxygen here. So that's why it's not a process of combustion. If anybody asks you, what is happening in the sun? Is some kind of fuel burning there? Of course, some kind of fuel is undergoing some reaction, but there is no oxygen availability there. It is not a process of consumption. It is not a process of combustion in sun. In sun, there is nuclear fusion reaction that is going on. Nuclear fusion. We also call it as thermonuclear fusion reaction, where hydrogen combines with itself to form helium and this helium breaks up again. So sun goes through a process of nuclear reaction which gives you a lot of heat and energy. And in fact, we'll talk about this in our subsequent discussions when we move to the class 9, class 10. We'll talk about thermonuclear fusion reactions at length also. But this is just information for you from NCERT. Right, let's talk about combustion processes. We understood what is combustion. A fuel burning with oxygen. A fuel burns with oxygen. When we heat it, it undergoes the reaction of combustion. What kind of combustion processes do we observe? Now we observe three kinds of combustion processes. One would be a rapid combustion process. Another would be spontaneous combustion process. The third one is basically explosion. See, rapid combustion. What is the meaning of rapid combustion? In rapid combustion, the classic example would be gas. The gas burns rapidly. It produces heat and light. But remember, spontaneous combustion also gives you heat and light. There is a small difference between rapid combustion and spontaneous combustion. The difference is, in your rapid combustion, you need to ignite it. That means the reaction has to be ignited. It has to be initiated. Whereas in a spontaneous reaction or in a spontaneous combustion, the combustion process can start automatically by itself. Apart from that, since it has to be ignited, means I have to give external heat. That is what we do at our home. When I go to home, there is a stove. That stove is connected to LPG cylinder through a pipeline, and I switch on the knob. You can see the you can hear the hissing voice of the gas also. Then you take the lighter and you provide it heat. What does that lighter do? It gives a spark, and that spark is nothing but the ignition. Here, there is no need of external heat to be given. Specifically, ignition is not required. And in the rapid combustion process, large amount of heat and light is given in a very short time. But in a spontaneous reaction, in a spontaneous combustion, small amount of heat is evolved. Although once a spontaneous reaction starts, it can lead to huge amount of combustion elsewhere also. So a classic example of this is rapid combustion. You can see in your gas stove, whereas a spontaneous combustion is something that you see, say for example here, during extreme summer season, we do talk about forest fires. Now the question is, has anybody ignited or has anybody given it power? Spontaneous combustion takes place here because of extreme heat, the dry grass sometimes catches fire. Yes, there can be some sort of anthropological intervention also. For example, say if you're a tourist, you have gone into jungle or a forest as a means of traveling, as a means of excursion, and you are using matchbox or matchstick, and that matchstick still has some amount of fire, that can lead to a forest fire. Or if someone is smoking and after smoking they simply throw the cigarette butt, that can also lead to some sort of forest fire. Anthropological reasons are there, but there are natural causes also. For instance, because of wind, if say two stones they undergo friction, then some amount of heat is generated, a spontaneous combustion reaction might start, right? So this is an example. In forest fires, it is generally spontaneous kind of combustion that we observe without any sort of initiation. Automatic initiation takes place. Apart from this, we also have explosive combustion or explosion. Now explosive combustion are generally intentional. We see that during the festivals of Diwali, right? During Diwali, what do? We burn firecrackers, and in the firecrackers, the fuel is in such a concentrated way, as soon as we ignite it, there is an explosion giving us heat and light. So different kinds of combustions can be seen, and for all these, you do know there is oxygen required, there is heat required for the reaction for sure, right? So combustion and its types. Examples also I have spoken about forest fires, an example of spontaneous fire. Now apart from this, when does it start? For example, if I have to switch on the stove at my home, how much temperature do I have to reach, or what is the ignition temperature? The combustion starts when we reach the ignition temperature of that particular fuel or that particular combustible substance. And different substances have different ignition temperatures. Here are some of the examples. For instance, diesel burns at 210 degrees Celsius. Fuel oil, gasoline, petrol, it burns somewhere between 250 to 280 degrees Celsius. Now you are thinking, sir, where is the 250, 260 degrees Celsius coming from? You must have heard about something called as spark plug in your IC engine. Have you heard of this spark plug? Many a times, if you're riding a bike, suddenly the ignition goes off. You give your kick or you try to ignite it again. Sometimes it does not happen. Why? There is some problem with your spark plug, because of which the ignition is not happening. And remember, this spark plug has to run continuously, because in an IC engine, when the fuel is burned, after one combustion cycle, again the combustion has to run. That means spark has to be produced continuously, and this spark gives you temperature. The same applies for us also. When we light our stove, what do? We give lighter, and that lighter spark, it reaches that particular temperature. That is why the lighters are also designed in such a way, the spark that is created, it is at that high temperature. That's why you must have seen that if you take a lighter and if you directly hit it on your hand, right, by closing the mouth, you hit the lighter on your hand, you will feel some sort of a small current or a spark, right, which sometimes might lead to some allergies or burns also, right? So other things like paper have a little lower ignition temperature, around 220 degrees Celsius. Wood is a little higher, 300 degrees Celsius. That is why wood you have to continuously rub. In the early times when we did not have any matchstick or anything, there what we used to do, two stones are taken so that spark is created, and the spark reaches this particular temperature. So ignition temperature, as soon as we reach, combustion starts. But many a times you must have seen on the road or somewhere, suddenly the fire starts. You must have seen recently with some electric bikes. Now this happens because in battery there are certain chemicals which might catch fire at around 40 degree, 45 degree in extreme heat, right? One of such examples is phosphorus, especially white phosphorus. In fact, we have spoken about that in our previous classes. I told you phosphorus is stored in water, right? Phosphorus is stored in water. Why? Because phosphorus is inflammable. And remember, white phosphorus is inflammable. White phosphorus ignition temperature is somewhere around 30 to 35 degrees Celsius. That means as soon as the temperature is 30 degrees Celsius, 30 to 35 degrees Celsius, white phosphorus burns. It catches fire. But the same characteristics for red phosphorus are different. For red phosphorus, the temperature is a little higher. It is around 240 degrees Celsius. That is why white phosphorus is stored in water or stored in other liquids. Red phosphorus does not need any kind of storage. All right. Now, the story revolves around this itself. When does combustion start? Because we need to understand the history of matchstick also. It is written in NCERT. Now, every day we use our matchstick. There is a small wooden piece over which there is some kind of a reddish or a blackish deposition, and we rub that against specific matchstick layer or a specific matchbox itself. There is a small red line drawn over that, correct? But before we had these kind of matchsticks, during the ancient times, there were matchsticks which were created by making small pieces of pine wood, and they were dipped in sulfur. But later on, especially during medieval times and etc., we slowly and steadily started to develop the concept of matchstick along with other chemicals. For instance, a mixture of antimony trisulfide and potassium chlorate was used along with white phosphorus. Remember this, along with white phosphorus, and matchsticks were created out of this. But this led to so many problems for people who are working in the matchstick industry, people who are working both for the manufacturers as well as the users. It was quite hazardous because they used to use white phosphorus along with antimony trisulfide and potassium chlorate. But in the modern times, these days, the matchboxes or matchsticks that we have a matchbox. In it, there is a matchstick. Sometimes the matchstick is made up of wax or wood also. We have seen that. But there is always some kind of deposition over the tip. And that deposition is nothing but antimony trisulfide and potassium chlorate. And you have to now rub it against a surface. That surface is also provided on the matchbox itself. That surface is made up of red phosphorus. Red phosphorus does not burn, but as soon as I rub this tip of the matchstick, that is antimony trisulfide and potassium chlorate, some amount of white phosphorus is formed, and immediately the matchstick ignites. So concept which was there used before, which was hazardous for the manufacturers as well as users, it has been rendered safe by using red phosphorus instead of white phosphorus. But ultimately, you need to understand, when I rub the matchstick against the matchbox, some amount of white phosphorus is formed. Some amount of red phosphorus is converted into white phosphorus, which immediately catches fire because its ignition temperature is only around 30 to 35 degrees Celsius. That's the history of the matchstick. Again, from combustion, we came to this particular knowledge. Now, the next thing, if I start a fire, say accidentally I start a fire. If I want to light a stove, I do it, but accidentally, say for instance, forest fire. If there is a fire, combustion is going on. How do I stop it? How do I end it? See, I told you, combustion is a chemical process. And for this chemical process, there are three ingredients needed. One is the fuel, that means a combustible substance. The other one is air, which contains oxygen. And the third one is heat. Now remember, whenever something is burning, since it is burning, it is continuously providing heat, and the fuel is also available, air is also available. That is why combustion process goes on till the fuel ends. Now imagine there is a forest fire, or imagine there is a fire in this building. As of now, I'm teaching. Suddenly there is a fire. What do? I have to stop this fire. How do I stop it? Since there are three ingredients, I can remove any one of these, right? I can remove heat, I can remove oxygen, or I can remove fuel. There are three things: remove the fuel, remove the oxygen, or remove the burning material, remove the heat. That means by cooling the burning material, remove the heat out of it. Three things. That is why whenever there is a fire, what do? The first instinctive reaction that we have, somebody says fire, fire, we take water and we throw water on that fire. Why? Because water basically takes away the heat. Water basically takes away the heat. And once the source of heat for the reaction, for the combustion reaction is taken out, then the combustion reaction can be stopped. But many times you must have seen, in fact, wherever you're watching, if you're in a company, if you're in some sort of organization, even at many offices, railway station, bus stops, you must have seen something like this, these cylinders. Now, these cylinders are actually fire extinguishers. They extinguish fire. That means they stop the combustion reaction. And these contain carbon dioxide. Now you must be thinking, sir, why carbon dioxide? See, carbon dioxide is one of the byproducts of combustion. As I told you, if a fuel contains carbon, carbon burns with oxygen to form carbon dioxide. Now you are telling, sir, carbon dioxide itself is used now as extinguisher. It makes sense. Why? First of all, carbon dioxide is heavier than oxygen. What will happen is, it's a byproduct itself. That means it's a combustion byproduct. I simply apply carbon dioxide on the fire. First of all, it will form a blanket because it is heavier than oxygen, and it cuts down the oxygen supply to the combustion reaction. That's why we use carbon dioxide as fire extinguisher. In fact, you must have seen so many experiments. I was watching one of the YouTube videos recently where one of the person was doing this particular experiment. You must have seen, take some vinegar and put some baking soda in it in a jar, and the reaction takes place, carbon dioxide is produced, and simply now that carbon dioxide gas, it's heavier, it can be poured, not the liquid, but gas can be poured on a burning flame, the flame goes off. You must have seen those experiments, right? That's why carbon dioxide is used as extinguisher. Clear? Right, let's move on. Now talk about the second part, flame. We spoke about combustion. Now we need to talk about flame. Now, what is flame? You must have seen, whenever there is fire, there are flames of fires, or we can see simple flame with our candle, with our Bunsen burner, or with simple kind of a kerosene lamp. You can see the flame is here. But many a times there is heat, there is some sort of light, but flames are not seen. Especially the question is here, does charcoal produce any flame? Charcoal does not produce any flame, but it burns. Charcoal burns, but it does not produce flames. So when is this flame formed? Our gas, it gives us flame. Because of that flame, we use it for cooking. When is a flame formed? See, flame is formed when the fuel is burned, and the portion of that burned fuel, it gets vaporized. And this vapor, it further reacts with oxygen molecules to give us a flame. And a steady flame is very helpful for many applications. We use steady flame as a source of light here. This kerosene lamp is used as source of light. Candle light, again a source of light. Or I showed you the stove burner. That stove burner also has a steady flame which is used for cooking food. But whenever we look at a flame, now we'll talk from the perspective of candle flame. Every flame has certain characteristics, different zones. We need to understand this. Now, this is a typical candle flame which burns through different zones. You can see here the candle is burning. This is the burnt wax or the molten wax which is going down. There is a small wick. Around that wick, you'll see one zone, you'll see a yellow zone, and then you'll see some sort of blue zone in your flame, right? So there are three different zones in any flame. The innermost zone is actually the black zone, which is surrounding the wick. Now, around the wick, there is no combustion taking place. Please remember, around the wick, there is no combustion taking place. That's why do an experiment today. Burn a candle, and then directly take a small pin or a wooden stick and put the wooden stick directly into the black zone or at the innermost level of the flame. You'll see that when you take that out, it does not even burn. Although some amount of partial combustion can take place, especially because of the wick or the wax which is vaporizing near the wick, and some carbon monoxide can be formed. So black zone, more or less no combustion takes place. Then there is a yellow zone. You can see around the flame, yellow zone. Here hydrogen burns, different fuel composition burns, hydrogen burns, carbon forms carbon dioxide, hydrogen burns, it forms water, and it burns with luminosity. That means it gives you a yellow kind of light. It gives you yellow kind of a light. And then at the outermost level, the outermost zone, you will find blue burning. You will find blue burning, a blue kind of a flame. And this blue kind of a flame, it is a little poorly visible. But remember, here complete oxidation or complete combustion takes place, and that is why it is the hottest part. Please remember, whenever a flame is seen, the internal part of this flame is actually least hot because there is no amount of combustion which is taking place here. Then there is a middle part, which is yellow zone, which is moderately hot, and the highest temperature or the hottest zone of a flame is the outermost part, that is the blue zone. That's why you must have seen, whenever your gas stove at your home, when you cook, try to observe the flame that you switch on the stove. If it is blue, then there is complete combustion. That means your LPG is not being wasted. Your LPG will run for say a couple of more days. But whenever it is giving yellow flame, that means some amount of incomplete combustion is taking place, oxygen availability is not there, and you will see that your LPG cylinder will be over very, very soon, because the LPG is being wasted, heat is not properly extracted. We are not using the fuel very efficiently. That's the meaning of that, right? So flame. Now, when we talk about a fuel which burns with blue kind of a flame, it is the efficient fuel. Now for that, complete oxidation has to happen. That means oxygen availability should be there. So a fuel has certain characteristics, or it should have certain characteristics, so that we can use it effectively in our day-to-day lives. A fuel, first of all, it must be combustible. Yes, it is better if it is cheap, right? Because I do not want very costly fuels. So a fuel has to be cheap, it has to be readily available. And that is why many people used to use wood before, right? Dry wood. It was cheap and it was easily available. But there was one particular problem. Its efficiency was very low, and it used to give a lot of gases and residues, which leads to pollution, which leads to problem of global warming. But we need to understand that fuel should be cheap and readily available. Fuel should be easy to store, and they should be easy to transport as well. That is why we face a lot of problem with our LPG cylinders, LPG gas, or the natural gas storage and transportation. It becomes a huge problem. Apart from that, a fuel should have slow burn rate. If it burns slowly, that means I can control the combustion and it burns fully. I can use that fuel very efficiently. It should also have optimum ignition temperature. It should not have very low ignition temperature like phosphorus, or else everything would be burning. It should not have very high ignition temperature, because to start the combustion reaction, it is going to take a lot of time. So it should have optimum temperature somewhere around, say, petrol or diesel, 200 to 280 degrees Celsius. It's very fine. Apart from that, it should leave very small amount of residue and gases. Now, this is a very important thing today. Why? Because we talk about sustainability, we talk about environmental protection. So residue or gases has to be very minimum, and it should be highly efficient. Now, what is the meaning of this efficiency? Sir, you mentioned fuel efficiency now twice or thrice. What is this fuel efficiency? An ideal fuel should have all these characteristics. But fuel efficiency is actually calculated through a term called as calorific value. Calorific value means how much calories are released, or how much calories are given by per kg of your fuel. That means if 1 kg of fuel is burnt, how much kilojoules of energy is released. That is the meaning of calorific value. And higher the calorific value, better the fuel efficiency. But remember, higher the calorific value, it should also satisfy to these things. For instance, one of the best fuels that we have is hydrogen, which has largest fuel efficiency, somewhere around 1,50,000 kilojoules per kg. But remember, it becomes very tough for me to, first of all, store hydrogen. its ignition temperature would be rather, its ignition temperature has to be maintained, sustainable reaction has to run, and remember, controlled combustion has to take place. Controlled combustion, it becomes very tough. Apart from that, you can see here cow dung cake, it has very low calorific value, it leaves a lot of residues and a lot of gases. Wood, it has decent calorific value around 17,000 to 22,000, but it also gives you a lot of gases, incomplete combustion, and residues, which leads to global warming. Coal is there. Coal releases a lot of carbon dioxide, sulfur dioxide, other residues are also there. Ash, how to manage that? Petrol, kerosene, diesel, methane, CNG, these are some of the fuels which leave very little residue. But again, petrol, diesel, methane, all these things, not methane, petrol, diesel, kerosene, they release a lot of greenhouse gases. We know that. So we have to select the fuel which has these characteristics. It should be easy, it should be easy, cheap, easily available, easy to store, easy to transport, higher fuel efficiency, it should have optimum ignition temperature. But nonetheless, combustion itself leads to a lot of problems. Now we spoke about combustion and flames, but combustion itself, it leads to a lot of problems. Why? Because combustion is a reaction. I told you, fuel burns with oxygen to give you heat and light, but along with heat and light, it also gives you a lot of residue and byproduct. If wood is burnt, it gives you ash. As a byproduct, it gives you different harmful gases. For instance, if there is incomplete combustion, then carbon monoxide is released. Solid fuels, they leave a lot of solid residue in form of ash. Now what do I do with that ash? How do I handle that ash? If I burn other fuels, smoke is produced. Even if there is complete combustion, carbon dioxide is produced. Carbon dioxide is a greenhouse gas. If I burn fuels like coal and diesel, there is sulfur dioxide which is released because it contains a lot of sulfur in it. Unburnt carbon as a soot, it leads to global warming. It leads to respiratory problems to us. Carbon monoxide, which is because of incomplete combustion, it leads to many problems. It is a poisonous gas. It gives you many respiratory disorders. Over all this, whenever we go for combustion of fossil fuels, there is a lot of greenhouse gas release. There is a lot of residue which is left out, which leads to problem of global warming. This problem of global warming ultimately leads to problem of climate change. And whenever large amount of carbon dioxide, sulfur dioxide, nitrogen dioxide, or oxides of nitrogen and sulfur are released into the atmosphere, ultimately we have seen it leads to a problem called as acid rain. In fact, we'll discuss about that in our future classes also. Acid rain. If there is spontaneous combustion, forest fires are a possibility which leads to large scale destruction of forests. So combustion has its own disadvantages. Combustion reaction, especially undesirable products out of combustion, have to be eliminated or have to be reduced to minimum so that it does not have many adverse consequences on environment, on humans, on entire ecosystem itself. So combustion, on one hand, it is very useful for us for heat and light, but on the other hand, it also has many undesirable consequences. So be very careful while using these fuels. That is the discussion for combustion and flame from chapter 8. That's the end of our discussion. Please remember, if you have liked this video, if you want to follow me, if you have any suggestion, you can always follow me on this particular ID at the rate Rahul Sai 222. Thank you for watching this video. Jai Hind.